A question of central importance for the organization of industry is whether production takes place most efficiently at large scale rather than small scale, that is, where large and small are defined relative to the scale of the relevant market. The technical property of the production function used to describe the relationship between scale and efficiency is called returns to scale. The term tells us what happens to output when all inputs are increased by exactly the same proportion. Because returns to scale refer to a situation in which all inputs are variable, the concept of returns to scale is an inherently long-run concept. A production function for which any given proportional change in all inputs leads to a more than proportional change in output is said to exhibit increasing returns to scale. For example, if we double all inputs in a production function with increasing returns to scale, we get more than twice as much output as before. Increasing returns to scale often result from the greater possibilities for specialization in large organizations. A production function for which a proportional change in all inputs causes output to change by the same proportion is said to exhibit constant returns to scale. In such cases, doubling all inputs results in a doubling of output. In industries in which production takes place under constant returns to scale, large size of an organization is neither an advantage nor a disadvantage. Finally, a production function for which a proportional change in all inputs causes a less than proportional change in output is said to exhibit decreasing returns to scale. Here, large size is a handicap, and we do not expect to see large firms in an industry in which production takes place with decreasing returns to scale. So, we have seen that for an organization, the production function could exhibit increasing returns to scale, constant returns to scale, and decreasing returns to scale, depending on the nature of its operations and the business in which it operates. Let me introduce another dimension here. The scales of operations are dependent on the level of production too in most cases. A production function need not exhibit the same degree of returns to scale over the entire range of output. For clear understanding, let's have a look on following isoquant map of a particular production function. There may be increasing returns to scale at low levels of output, followed by constant returns to scale at intermediate levels of output, followed finally by decreasing returns to scale at high levels of output. A simple relationship exists between a production function's returns to scale and the spacing of its isoquants. Consider the isoquant map. As we move outward into the isoquant map, the particular production function whose isoquant map is shown in the graph exhibits increasing returns to scale in the region from A to C. Note, for example, that when we move from A to B, both inputs grows by 100%. Also, output goes by a factor 3. Likewise, when we move from B to C, both inputs grow by 50%, while output grows by 100%. In the region from C to F, this same production function exhibits constant returns to scale. Note, for example, that when we move from D to E, both inputs grow by 25% and output also grows by 25%. Finally, the production function, whose isoquant map is shown, exhibits decreasing returns to scale in the region to the northeast of F. Thus, when we move from F to G, both inputs increase by 16.7%, while output grows only by 11.1%.
Very interesting. However, I seem to be lost a little. Earlier we were talking about diminishing returns, and now we are talking about decreasing returns to scale. Please help me understand if they are the same or different.
Again, a very good question. It is important to bear in mind that decreasing returns to scale have nothing whatsoever to do with the law of diminishing returns. Decreasing returns to scale refer to what happens when all inputs are varied by a given proportion. So, when the output does not increase in proportion of increasing all inputs in unison, we are talking about decreasing returns to scale. The law of diminishing returns, by contrast, refers to the case in which only one input varies while all others are held fixed.
Okay, but still not very clear. Initially, in case of diminishing marginal return, you were saying that output will fall because other inputs are fixed. So, over a period of time, workers will become unproductive. But in long run, we are changing even fixed inputs. Still output is decreasing. Why? I'm not clear.
In other words, your question is, if the production function Q is equal to F to the function of K and L is a complete description of the corresponding production process. It is difficult to see how any production function could ever exhibit decreasing returns to scale in practice, right?
Exactly.
The difficulty is in the ability to duplicate the process used to produce any given level of output and thereby achieve constant or possibly higher returns to scale. To illustrate, let's take the case of constant returns to scale. Suppose, first, that Q0 is equal to F to the function of K0 and L0. If we now want to produce two Q0 units of output, we can always do so by again doing what we did the first time, namely by again combining K0 and L0 to get Q0 and adding to the Q0 we already have. Similarly, we can get 3Q0 by carrying out f to the function of K0 and L0 three times in succession. Simply by carrying out the process again and again, we can get output to grow in the same proportion as an input, which means constant returns to scale. In cases in which it is not possible to at least double our output by doubling both K and L, we seem forced to conclude that there must be some important input besides K and L that we are failing to increase at the same time. Beyond a point, in any organization, there comes an issue of how to manage resources optimally so that the efficiency that was witnessed when the organization is small is maintained then too. This input is variously referred to as organization or communication. The idea being that when a firm gets past a certain size, it somehow starts to get out of control. Others claim that it is the shortage of managerial or entrepreneurial resources that creates bottlenecks in production. If there is indeed some unmeasured input.